Okay, notes number 9, we were talking about the greatest common factor today. And usually we just write GCF because mathematicians are lazy and they like writing as few words as possible. Okay, so today we're going to talk about what's called the greatest common factor. And we're still going to be working with factoring our trinomials as well. So it's going to involve both. What is a trinomial?
Like a binomial.
Like a binomial, but with 3. Tri means 3. Elton. Yeah, you're not tricking me. Put your phone away. Okay, so our goal today, our objective is students will be able to factor out a greatest common factor I'm just going to write GCF for greatest common factor. Then factor the trinomial that is left. Now we don't have to do these two things together. We can just greatest common factor, or we can just factor a trinomial. So we're going to see both. We're going to see just factoring a greatest common factor. We're going to see factoring the greatest common factor, then needing to factor a trinomial. Or we might just see factoring a trinomial itself. Remember, a trinomial is 3 terms. So when we are factoring a greatest common factor out, we learned factoring a trinomial is backwards of multiplying two binomials. Finding a greatest common factor is backwards of distribution. So let's look at a distribution problem. If we need to do this backwards, we need to know how to do it normally. Distribution. So we know how to distribute. We've been practicing our multiplication of polynomials quite a bit. We know how to distribute this. We're multiplying things together, and when we distribute, we multiply the coefficients together, add the exponents. So we multiply 5 times 3, 15, but we add the exponents. So what is my new exponent? 4. So then we multiply again. 5 times negative 8. Negative 40. X to the third. Because we have 2 here. What's the exponent on just the plain old x? 1. So 2 plus 1 is 3. And then we multiply again. 5x squared times 10. 50x squared. So again, we're trying to do this process backwards. We're trying to start here and end here. So we're trying to start with 15x to the 4th minus 40x to the 3rd plus 50x squared. And we're trying to get back to the parenthesis part as our answer. So just like when we did factoring a trinomial was backwards of multiplying a binomial. Greatest common factor is backwards of distribution. So when we are doing this backwards, when we did this normally, we multiplied 5 times 3 to make this number, 5 times 8 to make this number, 5 times 10 to make this number. How could I get these inside numbers if I'm going backwards? How could I get from a 15 to a 3? We divide this time. So we divide by 5. That makes the 3. If we divide 40 by 5, that makes the 3. If we divide 50 by 5, that makes the 10. What about the variables? If I have x to the 4th to x squared, what do I have to do with that 2? This time we minus. So we do the backwards of both. This time we're going to divide into our coefficients and minus our exponents. So instead of timesing and adding, we're dividing and minusing. The opposite processes. So let's try an example. So let's say we have 3x to the 5th minus 18x to the 4th plus 27x squared plus 9x. So we don't already know what the answer will be on this one. When we did the previous stuff, we knew the answer because we had done the original problem first. But we can figure out something that divides into every single number. So we're kind of asking ourselves the question, what divides? And I did already hear the answer. Someone said 3. I think it was Tanner.
Yeah.
So what divides into every coefficient? When I say coefficient, what do I mean by coefficient? The number in front of x. So we have a 3, an 18, a 27, a 9. Those all divide by 3. It's usually easiest to start with the smallest number, which isn't necessarily the first, but 3 is the smallest number. There's only 2 things that divide into 3. 1 and 3. Bless you. Okay. So if 3 didn't work and we could only use 1, we wouldn't have a greatest common factor necessarily. So we can divide these all by 3, but we're still not quite done yet with our thought process because we also have to consider the variables. We have to ask ourselves, does every term have a variable? If they don't all have variables, we cannot factor out a variable. They have to all have variables. Does every term have a variable? If so, which one has the smallest exponent? The thought process will actually take a lot more room than the actual problem. Or, sorry, smallest exponent. I think I said that first, but hopefully. So looking at this, we have x to the 5th, x to the 4th, x squared, and x. Which one has the smallest exponent? Just plain old x. What is the exponent on just plain old x? 1. That means when I factor out my variable, we're going to take out that x. We can only take out the smallest one. So we would have 3x to the 1st. So the answers to those questions go outside the parenthesis. You do not have to write x to the 1st if you don't. But again, usually for notes I write a little more detail. But if you can skip to just 3x, that's fine. Doesn't matter. And then we have to figure out what goes inside. Well, we have 1, 2, 3, 4 terms up here. we should have the same amount in our parentheses. We should have 1, 2, 3, 4 spots that we need to fill. And we find those by dividing. If I take 3x to the 5th and I divide by what we're factoring out, that will give me what goes inside. So we do 3 divided by 3, 1. And we subtract the exponents, 5 minus 1. You could just put x to the 4th. You do not have to put the 1. Then we divide. Again, we're always dividing by this same thing. Just like when we distribute, we always multiply by the same thing. So we divide again. What's negative 18 divided by 3?
6.
Negative 6. And we subtract the exponents. 4 minus 1 is 3. And just like Ms. Hagren said, if you look at her box, if we're dividing our variables, we minus the exponents. So we divide again. 27 divided by 3 is 9. We subtract 2 minus 1 is 1. And then we divide 3x to the first into 9x to the first. If our exponents match, those cross out. Made that way too big because we just get 9 divided by 3 is positive 3. So we are just doing backwards distribution. We're figuring out what divides into all of it. Yes. So we could have just a number factor out. We could have just a variable factor out. We don't have to have both. I'm going to do an example, and it's only going to have one thing factor out, either just a number or just a variable. So we still have to consider both. We have to consider, is there a number that divides into everything? And does every term have a variable? We should ask ourselves those two questions every time. So let's start with a number. Is there a number that divides into everything? Ben says 4. Is there any other number that divides into everything? 2. Which one should we pick? Should we pick 2 or should we pick 4? I'm hearing both. Okay. So, I'm hearing some people say 2, some people say 4. Ben, you're pretty certain it's 4. Why do you think it's a 4? Okay, because 4 is bigger. That's exactly our reasoning. Because 4 is the bigger number, we want to actually pick 4. Even though 2 would work, we could actually factor again. You have a question, or you were saying 4? Okay. So, we have 4 that can divide into everything. What about variables? Is there a variable on every single term?
No.
Which one doesn't have a variable? 32. That means I cannot take a variable outside. We just have 4 outside. So now we divide. This time we're only dividing by 4. So our exponents will not change. We're going to still have x squared. We're still going to have x. We just have to divide the 4. So 16 divided by 4, 4x squared. 8 divided by 4 is 2. And 32 divided by 4 is 8. So I want to do one more example where all we can factor out is a variable. And then I'm going to have you try a problem, and then we're going to take a problem where we can factor out a greatest common factor, and then still factor our trinomial. It's only 2 steps.
Hey, why doesn't that still work?
It does. My twin is next door. I just wanted to do, but she wasn't there for most of me greeting people. because today's twin day for homecoming week.
I know, but.
So that way, when people are walking in, they could see us dressed as twins. That was the only reason why.
Tyler, come in here.
Maybe at the end of class.
No, just tell her. It's okay if she's teaching in class. You're teaching in class too.
Yes.
Can I use it after Danny?
Yeah.
No. Can I use out the plastic?
Students and ninja.
Okay. 5x to the 6th minus 7x to the 3rd. Now notice, we don't have to be any certain size polynomial to have a greatest common factor. We've worked with one that has 4 terms, we've worked with one that has 3 terms, we've worked with one that has 2 terms. Doesn't matter, we can always check for a greatest common factor. So we look at this, and first we ask ourselves, is there any number that divides into both 5 and 7?
No.
1, we don't care if it's a 1. If it's just a 1, we don't use it for a greatest common factor. Technically it is a 1, but we don't really need to worry about it, because is dividing by 1 going to change anything? No. So then we look, do they all have variables? Yes. Which one is the smallest exponent? 3. X to the 3rd. So, on the outside we have x to the 3rd. I could write 1x to the 3rd, or I can just write x to the 3rd. It doesn't matter, you can write it either way. And then how do I figure out what's left? Subtract exponents, so really we're dividing, but after we divide, by dividing, that means we subtract our exponents. So 6 minus 3 is 3. 3 minus 3 is 0, so those disappear. So we get x cubed times 5x cubed minus 7. So I'm going to have you guys try a problem. Does everyone have this down before I go to the next page?
No. Yes.
I'm going to pause for a second.
Yes.
You realize we're recording today, right, Mohammed?
You never told me that.
You sounded so stupid about right there.
Yeah, we're recording Jill or something. Like she records it on the.
Yeah. I record it on my iPad. You can't see anybody's face. It's just
Oh, so it's all good.
Voices.
it's just voices, and like it'll show the board. And then I post it on my YouTube page. So if you need to rewatch the lecture, or if you miss a day, you can watch the lecture.
We can hear ourselves talking in your video.
Yeah. Right now, with so many people talking, it'll probably be mostly just yeah.
Mostly gonna be my
And the further I get away from it, the
Follow me on Instagram.
the quieter my voice is. So if I get close to it, my voice will be louder. If I get far away from it, my voice will be quieter. Does everyone have this written down now? So I want you guys to try this problem.
Example. No pain.
I want you to find the greatest common factor on this problem. Hit the on button, go to new document number 1. You can either just hit 1 or you can, and then go ahead and say yes, since we did that one.
You have to use that calculator.
So then we want to add a calculator page. We added a list page on it, so just go back to our new document. So Jillian is saying, no, don't put an X. Why should we put an X? The 48 doesn't have an X. So this one is just a number.
So the last number
Then use 48. Yes, but I kind of assumed you would go time. She had been back for a while. So if you've not gone after him, you can go simply. Everyone should be trying this problem. Okay, I need everyone's attention back up front. Lexi, what did your group decide to divide out of everything?
2.
2. 2 was our greatest common factor. And then we have to divide. So Ryan, what did you get after you divided?
I
Good. Okay? So, we have factored out the greatest common factor. Once we have done that, we can factor this trinomial.
See,
Okay?
you didn't tell us that one?
I didn't. I was saving it till after you did the greatest common factor. So I can factor this trinomial, x squared plus 10x plus 24. When we factored a trinomial, what were we looking for? We were looking for a certain pattern. So we have 3 terms. What had to happen with the last term? We needed 2 numbers that did something to make 24. That times to make 24. We need numbers that multiply. Cody, can you go back to your seat, please? What about 10? What did those 2 numbers have to do to make 10? Add. So we want 2 numbers that multiply to be 24, add to be 10. So we look at 24 first. What are some numbers that multiply to be 24? Jade. 6 and 4. So she saw the 2 numbers right out. You may have started with 8 and 3, but what is 8 plus 3? 11, not 10. So because 6 plus 4 is 10, this checks out. That's the correct answer. So we still have this 2 out front. We leave 2. We have a 2. And then we found our 2 factors, x plus 6, x plus 4. So after you find your greatest common factor, you can sometimes factor further. Okay, I want to do just one more example, then I'll pass out the assignment.
How many examples?
Wow. You'll survive. Is that enough?
Yeah.
So, let's say we have
Okay, how many minutes do we got?
we have like 10 more minutes. So we find the greatest common factor first. Always look for your greatest common factor now. Oh, yes, you're correct. 3. Sorry. Keep thinking you're raising your hand, but you're just telling me the answer. 3. But this time I also have to look for a variable because every single term has a variable. What's my smallest exponent?
2.
Squared. So we have 3x2 out here. Now, again, you don't have to write all these division problems. If you can say, I know I'm dividing, just do the dividing. We know we're doing 3 divided by 3, which is 3 divided by 3, 1. 4 minus 2, because we subtract the exponent, 2. Now we do the next one. What's negative 18 divided by 3? Negative 6. X to the first. And then 27 divided by 3 is negative 9. Why don't I have any exponent on that last one?
The exponents are the same.
The exponents?
3x squared and 27x squared.
The x squareds cancel out. So now we need to check and see if this trinomial can also factor. Well, let's look at our factors of negative 9. What are some things with negative 9? 3 times 3. But we need one of these to be negative. So what do we get if we add these? 0. Which is not what we're looking for. We should have a negative 6. So those did not work. What else? 1 times negative 9. So we add these together. What do we get if we do 1 plus negative 9?
Negative
Those also didn't work. What do we do at this point?
How would you get like positive numbers? Or
Okay.
saying something about like getting negatives?
So I could also do like 9 times negative 1. We could do the opposite signs. But what happens when I do 9 plus negative 1? Positive 8. Still doesn't work. Have we used every factor of 9 we know?
Negative 3 times negative 3.
Negative 3 times positive 3. When we add negative 3 plus positive 3, we still get 0. So there was our last factor. It was the last one we could check.
No, I said negative 3 times
Okay, but that's a positive 9, and we need a negative 9. So what happens if none of our factors work?
Leave it
We
alone.
can't. We leave it alone. This is our final answer.
I just told you leave it alone.
I'm sorry, I did not hear you.
Well, that's rude.
I have selective hearing. Okay?